Hi there, future PEs. This is Wasim Asghar. In this video, we're going to go over digital systems, more specifically multiplexers, combinational logic circuits, Boolean logic minimization, and much more. And without further ado, let's dive into the content. So let us start with this first topic that I would categorize as Boolean logic. And this is coming from a question in the mini exam within the course. And the student is asking a very simple, straightforward question. The student is saying, "Hi, Wasim, I didn't understand how the value of I1 is 1. Kindly explain." So this is a problem. This is a multiplexer problem from the mini exam. And you can see that I1 and I2 are connected hardwired to a plus 5 volt source. Now, I believe that we did not directly um, encounter a situation in the on-demand lectures or the homework assignments where we had a voltage source connected hardwired to one of the inputs. But I believe that we did have scenarios where I had the inputs hardwired as ones and zeros. Do you guys remember that? Okay. So the question the student has is that how do we end up with a 1 for a high value? So, this is a selector switch setup, right? So when we have a S0, we have I0, right? And when we have a low, so this is grounded. Notice, so we have encountered this type of a situation where one of the inputs or one of the switches is grounded. So this is always going to be a 0, correct? Right? So the situation that we have is that we always have this guy as a 0, and the input that is connected to the selector for a 0 is Y. Okay. All right. Make sense, guys? So we have how many combinations? So if we work with S0 and S1, I want you guys to be very comfortable with truth table. Now, truth table, you don't have to use only when you are dealing with a flip-flop question. Okay, truth table can be applied for logic minimization. Truth table can be applied for making sense of input and output. So how are we going to create a truth table for this? Which one of, okay, let me actually further break this down because there are a few moving pieces over here. Which one is the MSB, S0 or S1? And which one is the LSB? Because all of these things are important, right? Which one is the MSB and which one is the LSB? Anyone? We discussed that, right? The most significant bit from the standpoint of input and the least significant bit. What do we look at? Subscripts, correct? So S0 will be a MSB or LSB, guys? S0 will be LSB, right? It is the least significant bit. And S1 is going to be an MSB, right? So the way that I'm going to create the truth table is actually S1 and S0, right? So the four combinations when we have two inputs are 0, 0, 0, 1, 1, 0, 1, 1, correct? Which one of these are not possible? For the case that we are looking at, which one of these are not possible? Please let me know in chat. If I label them 1, 2, 3, and 4, right? Possibilities. Which ones are not possible based on the circuit that I have shown here? Yeah, I would appreciate if you guys can use the drop down and select everyone. There are a lot of students who are sending messages, but those are private messages. Exactly. So the ones that are not possible are these ones, correct? And why are they not possible? Why are these not possible? It's all in the circuit because of the ground. Because we have grounded S1, correct? We have grounded S1. So the only possibilities that are available to us are the ones where S1 is equal to 0. Does it make sense? Now for these two possibilities based on S1 and S0, correct? So if I were to write this, I'm going to write this as S1 S0, okay, plus S1 S0, and then we're going to fill in these blanks. I'm just trying to break down this problem. The answer to the question that the student is asked is very simple. I1 is equal to 1, I2 is equal to 1 because the voltage is high. Make sense, guys? That's a short answer to that question. But I'm diving a little bit deeper into this problem to help you approach it in a systematic and a methodical manner. Okay? All right. So these are the only two possibilities, correct? Now, as far as S1 is concerned, let's say that we are entertaining the first scenario. What do I need to do with S1 and S0 when they are 0, 0? How do I represent them as far as the output equation is concerned? Do I represent them as S1 as 0, or do I have to do anything on top of it? And there's a hint. Not, yes, bar, hat. On which one? S1 or S0? On basically both. Why? Because both of them are equal to 0, correct? Right? Agreed? Because S1 is 0, so a hat should go on top of S1. As 0 is 0, so a hat should go on top of S0. Okay, let's look at the second scenario where we have S1 equal to 0 and S0 is equal to 1. So which one will have the hat? S1 or S0? S1 will have the hat. And do we need to do anything with S0? We can leave it as it is. Okay, so you see how systematically we are working through this? When you go through it in a systematic manner, you're not going to make mistakes. I can guarantee you that. But when you try and solve the entire problem, okay, in a single go, anyone can make mistakes, even if you know the concepts, because you have to sort of work it out in a particular sequence. And there are multiple ways to do it. Some students, I could have potentially eyeballed it and given you the answer by maybe just directly writing the equation. But even then, I could have potentially made a mistake. But if you take this approach, right, it will take a little bit more time, but at least even if you make any error, you will be able to sort of backtrack. Okay. All right. So we are here. Now, what's the next step? How do we fill in these blanks? This is a multiplexer, correct? So when my switch entries are input, okay, is 0, 0, low, the first scenario, which of these outputs are going to show up? Which of these inputs are going to show up on the output? So 0, 0 is going to select what? I0, I1, I2, or I3? The input values S1 as 0, when they're set to a 0, 0, are they going to pick up? Are they going to push forward I0 on the output, I1 on the output, or I2 or I3? I0, correct? Because 0, 0 tells me that I need to push the first input. And the first input in this case is I0. And when I'm doing a 0, 1, when I'm doing a 0, 1, so 0, 0, the easy way to look at it is that 0, 0 in binary, when converted to decimal, gives us what? 0, 0. If this is binary and if this is decimal, it is equal to a 0, correct? And a 0, 1, which is the only other scenario that we are dealing with over here, a 0, 1 is equal to a 0, 1 is equal to a 1. Correct? Simple binary to decimal conversion. So the first input is a 0. The second one is a 1, 2, and 3. So we have a total of 4. Correct? So if I'm selecting input 1 is corresponding to I1. Correct? So you guys can see that this is going to be I1. Right? Now, if we look at this, at this step, if we freeze here, it does not look like any of the given options, does it? Options are in X, Y. So what do we need to do in the next step? Pretty simple. Make the substitutions. There are a bunch of substitutions that we can make, right? Several substitutions that we can make over here. Let's start with S1. What is the value of S1, guys? S1 is hardwired to a 0, correct? So this becomes this. Make sense? Any issues with that? Any problems? So that's this. Okay. If you have any questions, please let me know. What about S0? If I look at S0 over here, right here, S0 is equal to, S subscript 0 is equal to a Y. So this basically is a Y bar. Correct? What about I0? I0 is a X. Okay. So S0 is equal to a Y. What about I1? And this is really the question that the student asked me. I1 is equal to plus 5 volt, which is a high, and a high is equal to a 1. So far, so good? Okay. Now let us see where we go from here. What is the naught of a 0? Naught of a 0 is equal to a 1. 1 dot y bar dot x plus naught of a 0 is equal to a 1 dot y dot 1, right? So you are basically getting, see, sometimes you can make these silly mistakes. I almost made a silly mistake over here. I ended up putting an extra bar on top of y. So you need to be extremely, extremely careful, correct? So we have x y bar plus y. Now, when you look at the solution, the options, I should say, I still don't see anything resembling x y bar plus y. Correct? So are we stuck over here? What should come to our rescue? Now, if you notice, this problem is really dealing with a multiplexer. But the way that I categorized it, classified it over here is Boolean logic. So what is going to come to my rescue when I'm looking at y plus y bar x? And I want to simplify it. I don't see any options A, B, C, or D as y plus y bar x. So there's a Boolean identity, which is not given in the reference handbook, but it is very commonly used in terms of minimization. In fact, if you are against the wall, this Boolean identity comes to your rescue. And it is called the law of disappearing opposite or Boolean combining theorem. There are different names for it. Okay. And that identity says that if I have, I'm going to write this underneath it, A plus A bar B, this is equal to A plus B. So why is it called the law of disappearing opposite? Because if A is our starting point, the opposite of A is A bar. By using this identity, what we've done is that we have made the opposite, which is A bar, disappear. You guys see that? So when I apply this to the result that we have obtained over here, which is this, if I apply law of disappearing opposite on this, if I consider y as A, y bar will become A bar and x is equal to B, the result I should get is a plus b, which is y plus x, which is equal to x plus y. Now, when you scan the options again, you're going to find this as one of the entries. Okay? Does it make sense? So how many moving pieces of knowledge were we expected to put to use properly? Starting out with the initial question that the student submitted, how do you handle plus 5? Plus 5 is a high. So if I wanted to make I1 and I2 as a low, what would I select? If I wanted to make it a low, a 0. A 0 is considered a low. In some cases, you also have negative voltages that are considered to be a low, but 0 or a negative voltage would be considered a low. Okay, so this was the first moving piece, because if you cannot make that connection, you will be clueless as to how to deal with I1 over here. Because the final answer doesn't contain I1. It contains X and Y. Okay, that's the first trick. The second trick, which I initially sort of emphasized on, and I know a lot of students make this mistake, maybe you guys were not able to initially appreciate this, is the confusion around MSB and LSB. Now, if you've gone through the live training content on demand, I stress this a lot. Why? Because if you're wishy-washy in your understanding of LSB and MSB, you cannot create this truth table properly. Okay. So the second step where I know students trip is MSB versus LSB. So once we've identified that the subscript that has higher value or the highest value is MSB and the one that has the lowest value is the LSB, then we should look at the possibilities for the given scenario. Started out with the truth table, translated that truth table into output values, then made the substitutions based on the variables and the details that are given to us. And then in the final step, we applied Boolean logic. Okay. Now, if you have gone through some of the practice problems in the on-demand course, the quizzes, the study guide problem sets, the homework assignments, and if you have made the effort to actually understand the concepts using the lectures and the live training explanations, combining the two properly should allow you to solve this problem within 3 minutes. But remember that if on the exam you see flip-flop counter, combinational circuits, timing diagrams, you have to plan such that these problems are more than likely going to take more, probably between 3 to 5 minutes. Okay, maybe even more than 5 minutes. So if I'm taking the exam, I see a flip-flop or a counter or a multiplexer or a decoder, okay, or a timing diagram, I'm just going to flag it and move on. Okay, I'll get back to these questions after I've solved the easy questions that are under 3 minutes. But as you can see, this is totally doable. You have to just execute the plan in a particular order. You can find tons of success stories of my FE Electrical and PE Power students over here. And if you want to learn more about preparation of FE Electrical and Computer exam and the PE Power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.